All right, so we're going to work out this problem right here, the how many liters of hydrogen gas will be produced at 2 atmospheres of pressure, 25 degrees Celsius, if you put 12 grams of magnesium in excess hydrochloric acid. Okay, so you're given this reaction. Okay, so when we're looking at this right here, it says how many liters of hydrogen gas. So it's looking for the volume of H2. And then it tells me that there is the pressure is 2 atmospheres. It tells me the temperature is 25 degrees Celsius. It also tells me that I have a mass, but of magnesium, okay, of 20 or 12 grams. So the thing about the ideal gas law is that you can't just put anything into the ideal gas law. It has to be a gas. And when we're talking about these variables, they should match each other. So if I have the moles of something, then that would give me the pressure of that thing. So you have to be careful about what you're plugging into this equation. So for this equation right here, I cannot just simply go find the number of moles of magnesium and plug that in, because it's not a gas. That's not going to help me get the volume of hydrogen. So when you're looking at these problems, okay, when you're looking at these problems, you're going to want to watch, okay, it's giving you information. It's asking you for the volume of H2, but then it gives you information of something else. Right there, that should tell you that it has to involve stoichiometry in some way. So when you're going from one substance to a different substance, stoichiometry is involved in the process somewhere. So when you're looking at gas stoichiometry, and we're not at STP, so if we were at STP, okay, 1 mole of gas is equal to 22.4 liters, okay? But we're not at STP, so this does not apply, okay? So that means we're going to be using the ideal gas law because we're not at STP, and we're going to be using stoichiometry because we're going from magnesium and we're interested in hydrogen. So I can't plug this into the ideal gas law because it's not a gas, okay? So the first step is going to be stoichiometry. Because I'm given an amount, I can't plug that into the ideal gas law because it's not a gas. So first step is stoichiometry. So I have 12 grams of magnesium. I want to go from my grams of magnesium, well, I'm interested in the hydrogen. So I'm going to go to moles of hydrogen. And I'm going to go to moles and stop at moles because that's what the variable should be for N. So I'm going to start with grams of magnesium, okay? And then in stoichiometry, you need to get 2 moles of what you have. Then you can go 2 moles of what I want, okay? And then I would stop there because that's what I'm interested in. I'm interested in getting my moles to go into this ideal gas law. So go from grams to moles. So once you set up your map, those are the units that go on top. Grams needs to go to the bottom. 1 mole is equal to, I believe it's about 24 grams. And then we're going to go to moles. Moles of H2 on top. Moles of magnesium will need to be on the bottom. Now, moles on top of moles, you're going to pull those numbers from the coefficients. So there's 1 magnesium for every 1 hydrogen. So 12 divided by 24 times 1 divided by 1, so it's just going to be 0.5 moles. Okay, so now I have moles of hydrogen. This is a gas. I can plug that into the ideal gas law. Okay, so that's what I'm going to do. I'm going to plug everything I have into my ideal gas law, and then I can solve. I need more space. is there no eraser function? Okay, so I'm going to erase all this. Okay, so now we're going to use the ideal gas law because now we've done the stoichiometry, we have the moles of the hydrogen. So now we can go back and do the next step. So my pressure was 2 atmospheres. Okay, my number of moles, we just solved for that. That was 0.5 moles, and that's of hydrogen as we solve for that. We're looking for the volume of hydrogen. We are at a temperature of 25 degrees Celsius, which is actually just going to be 298 Kelvin. You have to add 273 to that. And then we also know the R. R is going to be 0.0821 liters, atmospheres over moles in Kelvin. So now you're going to just plug that into the ideal gas law. So my pressure is 2. Volume is what we're looking for. Your number of moles is 0.5. That's 0.0821. And then your temperature is 298. And of course, make sure that all your units match the units in R. So then when you do this, you have 0.5 multiplied by 0.0821 multiplied by 298. That's going to give me 12.23. So divide both sides by 2. Should get roughly 6. 6.11 liters. Okay, so when you're looking at problems like this, look at what you're given. Okay, look what you're going to. Anytime you use the ideal gas law, it has to be a gas that's being plugged in there. So if you're looking for a volume, so if the question is ultimately asking you for a volume, but it gives you an amount of something different, you have to do stoichiometry first, and then you can plug it into the ideal gas law. Does anybody have any other questions about this? So I don't know how far people have gotten with the molar mass and density stuff. Does anybody have any questions on that? I can kind of quickly go over one of those. Okay, so what is the molar mass of 10 grams of a gas that has a volume of 2 liters, a pressure of 1 atmosphere, its temperature is 30 degrees Celsius? Okay, so when we're looking at that question, the first thing I like to do, I do this every single time. I'm going to pull out the information that was given to me. So what is the molar mass? So molar mass is what we're looking for. Okay, molar mass is really just a gram to mole ratio. So you need 2 numbers in order to get molar mass. You need to get the number of grams, and then you also need to get the number of moles. So if I'm looking in the problem, it says that I have 10 grams. So that would be my number of grams here. And then we have a volume. So we have a volume of 2 liters. Okay. We also have a pressure of 1 atmosphere. And then we have a temperature of 30 degrees Celsius. And of course, I can't use Celsius with gas laws. That's not a thing. So that's 303 Kelvin. So I have this information, okay? In order to get what I'm ultimately looking for, I need to get my number of moles. Well, I know that I have a volume, I have a pressure, I have a temperature. So anytime in your head where you start to see, okay, I have a volume, I have a pressure, I have a temperature, when you start to see those variables come up in your head, you know that you're probably going to be using this somehow. So if I need to get my number of moles, well, I have my pressure, I have my volume, I have my temperature, I know what my ideal gas law constant is. this is what I need in order to get my molar mass. So I'm going to use my ideal gas law first, and then I'm going to get my number of moles. Then I can go and look for the molar mass. So my R, remember, is going to be 0.0821 liters, atmospheres, moles, and Kelvin. Okay, make sure all your units match R. So I have atmospheres, liters, and then I have Kelvin. So now I can just plug it all in. So I have 1 atmosphere. I have volume of 2. I'm looking for N, and I'm looking at that, and my temperature is 303. So I'm going to plug all that in, and I'm going to solve for my N. Okay, so I should have 2 divided by 24.8 roughly. So my number of moles will be 0.08, but that's not my answer because I need the molar mass. So now I'm going to go that one more step and get my molar mass by taking my number of moles and then dividing it into my number of grams. So 10 divided by 0.08 will give me about 125. Okay, so does that make sense? It's really just like a 2-part problem. So anytime it's asking for the identity of a substance, or it's asking for a molar mass, well, what is molar mass? Molar mass is a gram to mole ratio. So if you have your number of grams, which they typically give you, you can solve for your number of moles with the ideal gas law. Does that help? All right, do you guys have any other questions for me? I do really recommend working through the packet with the molar mass and density problems. Make sure you understand how to do that, and then go into the gas stoichiometry stuff. I'm posting answer keys on that probably tomorrow. But I recommend kind of working through some of those, and then anything that you are like, I have no idea how to get this, circle it, and then when we have another conference, somebody can come in here and like say, can you do this one? Somebody have any other questions, or are we good? So I will let you guys go unless you have any other things. No problem. If 10.3 grams magnesium nitride, Crystal, quick question. Did you see it as a limiting reagent problem? Like, did you do the calculations for both? Yeah, okay. Yeah, you're gonna have to, like, it's limiting reactant, and you know, so you have to do both things to get the number of moles. So it's asking for the volume of ammonia. Yeah, you're going to have to figure out the moles of ammonia based on the 10.3 grams of magnesium nitride, and then you also have to do the same calculation for the water to see which one is limiting. Okay, so you have 10.3 grams of water, and then you also have 10.3 grams of the magnesium nitride, Mg3N2. Okay, so you're given amounts, you're asking for a volume, so you have to use stoichiometry first because, well, first of all, this right here, this is not going to be a gas for sure. So, if you're looking for volume, use gas stoichiometry or use the stoichiometry first. So let's go ahead and do that. Okay, so we're going to go from grams of water to moles of ammonia. And then we have to do the same thing down here. So we're starting with grams of water. We have to go to moles of water first. We always go to moles of what we have. Then we can go to moles of what we want. Okay, so I have 10.3 grams of water. 1 mole is equal to 18 grams. And then 1 mole of, oh, I'm sorry, not one. Okay, so now moles of water will go on the bottom, moles of ammonia on the top because that's what we want. So when we balance that, okay, so I'm going to balance it down here. You also need to make sure that you balance this before you do anything, because these coefficients are definitely not going to be like 1 to 1. Okay, so I've got 3 hydrogens too, so let's go ahead and make it 6. And then I would need 3 magnesiums and then 3 oxygens. Okay, so now I'm balanced. So when I'm looking at my ammonia, I've got 2 ammonias for every 3 waters. So that's going to give me 10.3 divided by 18 times 2 divided by 3. So that's going to give me 0.38 moles. Okay, so now that's for one of them. You still have to go through and figure out, okay, how much does this make now? So 1 mole of magnesium nitride, well, it's 24 times 3 plus another 28. So my molar mass here should be about 100. So now I'm going to do the same thing. I'm going to go to moles of ammonia. Moles on top of moles, I'm going to use my coefficients. So that's 1 mole of magnesium nitride for every 2 of these. So 10.3 divided by 100 times 2 will give me 0.2 here. So once I go through and I do all that lovely math, this is my amount of ammonia. Okay, so now that I have my amount of ammonia, I also have a temperature, I have a pressure. So in your head, every time you see those variables, a temperature, pressure, volume, you're probably going to be using ideal gas law. So now we're going to use this in the ideal gas law. So I'm going to erase all this. So my N is 0.206 moles. Okay, and then I am looking for a volume of the NH3. Okay, my temperature is 24 degrees Celsius, so that's going to be 297 Kelvin. And then I have a pressure of 0.989 atmospheres. And then I know my R is equal to 0.0821. So everything matches, atmospheres, Kelvin, moles. So now you just plug it into the ideal gas law. All right, so my pressure is 0.989. My volume is unknown. This is 0.206 multiplied by 0.0821 multiplied by my temperature of 297. So that times 0.0821 times 0.206. That's going to give me 5.02. This is 0.989 times V. So that divided by 0.989. Oh, yeah, so about 5 liters. Oh, okay. Yeah, don't worry about that too much. When you get close to an answer, more than likely your rounding would be an issue with, like, if you're using a very specific molar mass versus somebody else. Like, I just kind of like knew, okay, magnesium's close to 24, so I rounded it to that. So more than likely it could be something like that. So if you're close to the answer key, move on. Yeah, so, I mean, don't worry about that. Well, the quizzes so far have been multiple choice. Now on the test, more than likely I'm just going to have to go in and hand grade, because like there will be some multiple choice, but there will also be some, like, you know, numeric responses, but I can't set it up to do a range, so I'm probably just going to have to go in and hand grade that, and whatever, it's fine.